A salt hydrate is a salt crystal that has water included in it as part of the crystal structure. So it's part of what's bonded in there. And this is how we write it. That is a raised little dot there. And then the number of it, this gives you the ratio 1 magnesium sulfate per 7 waters. Look how we name it. 7 is hepta. And the thing to note is that a salt hydrate is not wet. It does not appear wet. It just looks like a crystal, like a solid. But when you heat it, that water will leave and you'll be left with just the anhydrous salt. So this is not the hydrate we're going to deal with, but what we are going to do is to determine what this number is for our salt. That's our quantitative chemistry, is to determine how many water molecules are bonded into that crystal, what the ratio is. An empirical formula tells you the lowest whole number ratio of the elements or parts that are present. And so that's what this is, an empirical formula. It says that we have a 1:7 ratio of those parts of the crystal. And of course, the one we're doing is not magnesium sulfate. This is just an example. It is possible to have a number up front here if it's not 1, like this X would be, but I will tell you our number in front is 1. It makes it a little bit simpler. So let's look at how the data would be. We're going to have a mass of the salt before it's heated, and after we heat it and those water molecules leave, we'll have a lower mass. Okay, and you need to know what these numbers represent. So the number when it starts, when you have the crystal, this is with water. Like this. And the number after this is the anhydrous salt. In other words, in this case, this would be just the magnesium sulfate without the waters attached. Okay, so this is pretty simple. We're going to start by seeing how much water it lost, because that will tell us how much of this original 2.92 grams were just water. So we'll subtract. Okay, so that's how much water was lost upon heating. In other words, that's how much water was in that crystal. How many moles of water were lost? So grams to moles, we can do that. Okay, and when we're doing empirical formulas, normally we carry a whole lot of digits. The thing is, in lab, you're going to have some experimental error. So it won't matter quite as much. Things won't come out perfect, and you'll have to round them to whole numbers anyway. But anyway, I'll do it like that. Okay. How many moles of anhydrous salt remain? And so you need to be careful. This is where you need to know this anhydrous salt is what's left after heating. So I need a molar mass first. And our compound in this example is magnesium sulfate. Okay, and then I'll take the mass that was remaining, and just to remind you I'm getting that right here. That was after it heated, the mass. Okay, and so now from the original crystal, I have a mole ratio. And that's what we want. Those numbers, these numbers here, those are a mole ratio and not a mass ratio. And so that's why we had to convert to moles on these. And then doing an empirical formula, we don't want to use these numbers that are not whole numbers. We want whole numbers and integers. So what we do is we divide by the smaller. So let's look at that. And then I'm going to divide these both by the smaller of the two, which is okay. And at this point, normally if these didn't come out to a whole, you would be multiplying by a factor. But this is experimental, and so there's going to be some error. So at this point, what you want to do is round this number to the nearest whole number to get your answer. And one thing to think about too, and I don't mind if you do this, is to just round it up to the nearest whole number, because if anything, this number will be too low, like you didn't heat it long enough. And so if you want to just round it up to the nearest whole number, whatever you get. So on ours, and so that's how we write the empirical formula. That's kind of raised. Put that separate to show we have 4. And then for the name, I would say the whole name of the salt. We put it down here. And then for 4 is tetra. And then for the water, I say hydrate.